Well, my name is Mahmoud Kiasari, and today we are here with another chapter of electrical circuit. So obviously you guys remember for the previous chapter we were talking about everything related to the series circuit, the power circuit, the combination of them, and also we mentioned a couple of ways that you can use in order to solve those kind of circuits in order to find the current and voltage, obviously, like the Thevenin and Norton. And at this point we are going to touch two more important toolkit that is going to help us just in case in order to solve those equations and those all of this questions related to the current and voltage for the time when the just Ohm's law is not going to be enough. So without further ado, let's talk about it. So as I just mentioned, at this point, we are going to touch the fact that sometimes that Ohm's law is not going to be enough. It means that your circuit is going to be a little bit complicated. So what you should do on that time? In this chapter, we are going to talk about it. So as I just mentioned, when Ohm's law is not enough, imagine that you do have a condition like this. At this point, you can see that the combination between the circuits is going to be a little bit too advanced for us. Just use V is equals R times I and then try to solve it. So we need a more professional toolkit. This chapter, we are going to see that what is that specific toolkit. So the very foundational question that we have to ask from ourselves is that what is the unknown? At the very first point, at the very beginning, we have to at least know that what we are looking for. We're solving a branch currents or mesh currents. By the way, when I'm saying that the branch current and mesh current, I will talk about it. What does it mean actually? But first of all, I have to specify which part of the circuit I'm looking for in order to find the current itself. Then I have to find the scope. How many mesh currents and how many mesh currents must you define? By the way, the one thing that I have to talk about before moving forward is the difference between a mesh and a loop. As you guys know, when I do have a circuit, for instance, like this, I can find the loop itself. A loop means that any closed path is considered as a loop. This one is a loop, this one is a loop, and this one is a loop. But with these specific loops, especially this one and this one, they do have specific kind of characteristic that we can call it as mesh. Mesh means that you do have a loop that you cannot divide it down into smaller loops as well. So when we are talking about mesh, actually we are talking about special loops that you cannot divide them down. So again, as I just mentioned, you have to specify the scope. What is the scope? How many mesh currents must you define? About the number of windows, that's just something about the mesh and not arbitrary loops. Then we have to talk about the physics. If the mesh current is negative, what does that physically mean? The actual current flows opposite to your assumed direction. As you guys remember, most of the time we consider the current that moves from a negative side of the source to positive side of the source. And then we have to talk about the law, which law is non-negotiable in the process itself. Kirchhoff's Voltage Law. About the mesh analysis, the only law that we are going to use or we're going to talk about it is about the KVL. As you guys know, KVL which says the accumulation of all of those voltages that you have beside your source is going to be as the same as your source. Or in a mesh or in a loop, if you have all of those voltages, it should be zero. And finally, the distinction. What is the critical difference between a mesh current and the current through a component? We are going to talk about all of them in detail. So let's have the blueprint. Let's identify the mesh. The very step one is that ensure the planarity. It means that redraw, if necessary, no crossing branches. As you can see over here, I do have one circuit into two form. The very first one is a little bit complicated because I do have some kind of wire is over another wire, and these two guys are somehow crossing each other or moving through each other. This part is going to make me a little bit confused. At this point, it would be better for me to redraw the whole circuit like this. So I do have very nice circuit. I do have my components. I do have some kind of the currents inside each mesh, and everything is connected to each other. So step number two is that I have to identify the meshes, count the windows. Again, the mesh is a loop that you cannot divide it down into some kind of more closed path. So these are going to be your domains. And finally, we have to assign the mesh currents. Consistent direction, it means that clockwise is your professional standard. It means that right now, by considering the fact that I do have I1 and I2, by considering that the clockwise is going to be direction of the current, it means that the current moves this way, and also for another one, it will move that way, I1 and I2. But here's the important part. What about current at this point? So at this point, based on the KCL, as you guys know, the KCL would says that the amount of current that gets in is the same as the amount of current that gets out. So I can say that at this condition, I do have my I3. So I3 is going to be accepted inside the KCL if I1 equals I2 plus I3. So if I would like to find the I3, I3 would be I1 subtracted by I2 itself. So this is from one direction. This is the direction of seeing I1 to the whole circuit itself. So what would happen if I look at the circuit from this point? If I would like to write down the KCL over here, the KCL would says that at this point I do have my I2, at this point I do have my I1, but the direction of I3 would be different. At this point, I3 would be I2 subtracted by I1. Why we are going to consider that? Because when we are trying to write down the KVL, one time you have to look at the first mesh, and another time you have to look at the second mesh. By having these two, you do have two unknown two equations. By having these two unknown two equations, you can finally find I1 and I2, and considering the I3 based on different perspectives is going to help you in order to solve that. So as you can see over here, for a resistor shared by mesh 1 and mesh 2, the voltage drop is going to be R times R times I1 I2, or R times I1 plus I2. So since it's going to talk about this perspective, and obviously the current should be subtracted, we are going to choose this answer. So let's talk about the non-negotiable rule for direction. As I just mentioned, whenever we are talking about the voltage, if we're moving backward, imagine that I do have a voltage source, that this part is positive and this part is negative. If I move it, reverse, and instead of just moving from negative to positive, move from positive to negative, I do have the voltage drop. Voltage is going to decrease. And if I do have this some kind of a resistance, as you guys know, if I move the current, and if I some kind of use the current in order to move from positive to negative, I do have this voltage drop again, negative R times I. And if I do everything backward, it means that if I move from negative to positive, it's a very key and important direction for the current itself. I do have a voltage rise. And if I just move backward for the resistance itself, instead of from moving positive to negative, move from negative to positive, I do have R times I itself. So at this point, I'm looking for the Cole algorithm. I'm looking for a multi-tool for analysis. As I just mentioned, the very first thing is about the identify. First of all, we have to find all of those meshes and assign current to each of them. Then I have to mark them, mark the resistor polarities. As I just mentioned, we have to consider a specific thing or a specific positive and negative for my components. At this point, we are talking about resistors in order to use them for see that do we have any voltage drop or we do have a voltage rise. Then we have to write one KVL equation per mesh. This is important. This is going to give us some clue that what is happening inside that specific mesh. Then we have to solve it. So the linear system, most of the time we do have two equations, two unknown. We are going to use that in order to solve it. Finally, we have to compute. We have to compute all of those requested values, and obviously at the end we have to verify that everything is going to be okay and our answer is right without any flaw. So let's look at this very simple question. As you can see over here, I do have two meshes. How I know I do have two meshes? First of all, I can find the loop. So if I would like to find the loops, the very first one is going to be this big one. This is the first loop. The next one is this one. This is the loop, and this is going to be another one. So far I do have three loops, but which one of those loops cannot be divided into a smaller one? This one and this one. So these two loops cannot be divided into a smaller one. So I would consider them as mesh number 1 and mesh number 2. So let's specify current for each of them. The very first current would be I1 like this, and the second current would be like this. As you guys know, one time my current would be moved from this to this point, which I considered as I1 subtracted by I2. Another one, the currents for the second mesh would be over here that I consider as I2 subtracted I1. You don't have to worry about the sign over here because the I2 subtracted I1 is going to be related to this one, and I1 subtracted I2 is going to be related to that one. You don't have to worry about it. So another thing that we have to do obviously is we have to specify polarity to our resistors. So we consider that negative, so we know for a fact that if I move from to here, actually I'm facing the voltage drop. So let's talk about it. Let's talk about this, some kind of KVL for each of them. As you guys know, for the KVL for the first mesh, my voltage source, what is going to be accumulation of voltage of R1, R3, and R2 itself, right? So I can say that the voltage that I do have as my source, 12 volts, equals to 4 ohms times I1, because the current that goes through here is I1. Then I do have another current that goes this way. From the perspective of I1, this current is equals to what? I1 subtracted by I2. Then I do have another current which is going to be just I1 itself. So far I do have 12 volts subtracted by voltage drop from the I1 is going to be negative 4 ohm times I1, and is going to be subtracted again from this voltage drop that we do have because of the 6 ohm. 6 ohm times I1 subtracted by I2, and again subtracted by 2 ohm times I1 equals to 0. This is the first KVL. The second KVL is going to be same scenario for I2. We do have a voltage drop because of that point. After that, what we do have our case over here, which is going to be a voltage source. Again, we do have a voltage drop because of 5 ohm, but at this point we do have a voltage drop because of 6 ohm, while I consider that my I3 is going to be I2 subtracted by I1. So I can write down the 6 volt as my source is going to face 3 voltage drop. The very first one is because of the 4 ohms, as you can see over here. The second one is because of the I2 that we do have it over here, and the final one is going to be because of the 6 ohm by using I2 subtracted by I1 equals to 0. If you rearrange these formulas, or if you rearrange all of them, you'll have two equations. And if you solve that, something like you're going to face an answer for that. And the answer is going to be your I1 and I2. So your I1 and I2 is going to be like this. Your I1 is 2.15 and I2 is 1.38. We somehow expected that, right? The I1 is the current that is related to the first voltage source, which is going to be 12, is bigger than this guy. Obviously, the current that caused somehow by the 6 volt itself. So obviously, you can find a voltage that across the R3 that moves out. Either you can use some kind of 6 ohms times I2 subtracted by I1 is going to be a negative sign, and you can use the 6 times I1 subtracted by I2, which is going to give you this number, as simple as that. So in order to be familiarized more with the concept itself, let's solve another question. So imagine that I do have this point. I do have this question, and right now I know everything about it. I know that I1 is 5 amp and I2 is 1 amp, but I have to prove it, obviously. So as we just had for the last part, I do have my first mesh, which is this guy, and I do have a second mesh, which is going to be this guy. And at this point, I just specified all of the signs or polarities to my resistance. So let's do it. For the first mesh, I do have my 28 volts as my source, and this 28 volt is going to be some kind of equal to all of the voltage drops that I do have for the first resistor and second resistor, first resistor and obviously R2. So I do it as 4 I1 plus 2 I1 subtracted by I2. Again, we are looking from the first mesh, but I'm looking from the first perspective. Then we do have the second one. We do have the 7 volt equals to 1 times I2 plus 2 times I2 subtracted by I1. So I do have two equations, and the only thing that I have to do, I have to expand the parentheses. I have to get rid of all of those numbers in one side. I have to put all of those numbers in one side and all of the variables in another side, and I can solve this equation. So 2 times I1 and 2 times negative I2 times I2, 2 times negative I1. So if I do that, my 28 volts would be equals to 4 I1 plus 2 I1 subtracted by 2 I2. Then I do have the 7 volt equals I2 plus 2 I2 subtracted by 2 I1. So if you rearrange that, what you got? So if you rearrange that, you would have 6 I1 subtracted by 2 I2 equals to 28. Then you do have 3 I2 subtracted by 2 I1 equals to 7 itself, right? So at this point, I have to somehow solve it. Either you can use elimination method, or you can use the matrix method, or you can use the substitute method. At this point, I'm going to use the substitution method. How I can do that? I'm going to use the first one. Why for the first one? Because as you can see, 6, 2, and 28 can be divided by 2. If I do that, what do I got? I do have 3, maybe I can just do it over here. I do have 3 I1, I do have 1 I3, and I do have 14. So that's the case. I do have this form. At this form, I can find I2 based on I1. If I do that, my I2 would be equal to what? My I2 would be 3 I1 subtracted by 14. Then I have to put it inside this equation. So if I do that one, what I got? 3 times 3 I1 subtracted by 14 subtracted by 2 I1 equals to 7. Is that so? So if I do that one, I do have 3 times 3 I1 and 3 times negative 14. It would be 9 I1 subtracted by 42 subtracted by 2 I1 equals to 7. So if I just again rearrange it, move the 42 on the other side and cancel out these guys, my 7I1 equals to what? Equals to 49. So based on that, I can find I1 and I2. So I do have as 7I1 equals to 49, and it means that my I1 would be equals to 7 amp. Right now, I do have my first current, and then I have to just put it inside one of those equations in order to find the next one. So I2 would be equals to 3I1 subtracted by 14. I do have that as I1 as 7, so it means that equals 21 subtracted by 14 is equal to 7 amp itself. Means that the answer that I have over here is completely wrong, and I1 would be equals to I2 as 7 amp itself. I can just verify it. I just verified that one in one of the equations. I can check inside the second equation, and I can simplify that both of them are going to be 7 amp itself. Simple as that. So let's look at another one. At this point, I do have one exceptional situation that my 10 volt, instead of just being in a normal way, is going to be vice versa. So at this condition, instead of just considering it as 10 volt as my source voltage, I'm going to consider it as negative 10. By this way, I can answer my question. Whenever you had something like this, try to some kind of consider that. So for the left mesh, I do have my 42, I do have my 6, and I do have 3. Again, so I do have 42 volts equals to 6 times I1 and plus 3 times I1 subtracted by I2 is going to first KVL. For the right KVL, as I just told you, negative 10 volt equals to 4 times I2 plus 3 times I2 subtracted by I1. Again, try to expand them. 3 times I1 subtracted by 3 I2, 3 times I2 subtracted by 3 I1. So if you do that, what would you got? You have 42 volts equals 6I1 plus 3I1 subtracted by 3I2. Then you have your negative 10 volts equals to 4I2 plus 3I2 subtracted by 3I1. So if you do that one, and if you try to some kind of simplify it more, what you got, you have your 6I1 plus 3I1, it would be 9I1 subtracted by 3I2. So I do have 9I1 subtracted by 3I2 equals to 42. Then for the second row, that's what? We do have 4I2 plus 3I2. So 7I2 subtracted by 3I1 equals to negative 10 volts. At this point, if I would like to find an answer, either I can multiply both sides of this guy by 3, and then I can eliminate this one from this one, or I can do any other way that you have in your mind. Let's do that. Let's multiply both sides by 3 of this guy. So what would you got? I would have a new one, would be 21I2 subtracted by 9I1 equals to negative 30. So if I add the whole equation with this one, I can cancel out these two together. So let me use another color. This one would be canceled with this one. So what would I got? 21I2 subtracted by 3I2 would be 18I2 equals to 12. So my I2 would be what? My I2 would be equals to 12 divided by 18. So 12 divided by 18 is something around 0.66. So let's consider that 0.67 amp. So this is my one of the currents. This is I2. Then try to find I1. It doesn't matter what equation you use. You're using this one or this new one. So I do have as 9I1 subtracted by 3 times 0.67 goes to 42. Then rearrange that. 9I1 goes to 42 plus 3 times 0.67. So 3 times 0.67 is something around 2. It's going to be 44. So my I1 equals to 44 divided by 9. So 44 divided by 9 would be something around 4.88. Maybe can consider as 4.9 amp. So far I do have my I2 and I do have my I1. Another thing that I have to do, I have to check it obviously inside all of these equations. Since we got this ones from the equations itself, it is very, very important to verify that. Imagine that I'm going to choose one of them randomly, for example, using this one. So 7 times I2 is 0.67 subtracted by 3 times 4.9 should be negative 10. So let's find that. So it somehow equals to negative 10.01. We still can consider as 10, so everything is okay. It means that our way is fine. So the only thing that you have to be careful at this point is that instead of just using the normal 10, since the direction is different of the second source, you have to consider the negative 10. So let's consider these two questions and see that we can solve them or not. As you can see, instead of just only 2 meshes, we do have 3. So I do have one mesh, I do have second one, and I do have the second one. First of all, I have to specify all of the currents. For example, positive, negative over here, positive, negative. It doesn't matter what way you choose, because at the end of the day, if you use your equations, they're going to cancel out each other, right? So I do have two sources. It means that one source is like this, and this guy equals, if I consider the KVL is a voltage drop over here, this guy is a voltage rise and a voltage drop over here. Then I do have this guy is going to be equals to the amount of voltage drop over here. And at this point, for the second mesh, the only thing I do have is voltage drop. So I can multiply, I can just add all of them together and I still have 0, right? Let's look at the very first one. So the very first mesh, the KV for the first mesh, which said what? Which says 7 equals to amount of voltage drop. I'm moving like this. Let me just use kind of this one for you to not get confused. I'm moving through this point for the first KVL equals to 1 times. As you can see, I do have this guy is going to be I1. This guy is going to be I2, also I2. Then I do have this part is going to be I3. Whatever between them is going to be a combination of the subtraction. So 7 equals to 1 times I1 subtracted by I2. Then I do have the voltage rise of 6. It means that since the voltage rise, 7 should be plus 6. Then I do have it as what? I do have another voltage drop because of this 2 ohm. So if I consider that, it would be plus 2 times what? I do have it as over here. I do have it as, if I consider the fact that one of the currents would be I1 and another current would be about the I2 itself. I do have it as 2 times I1 subtracted by I3. Sorry, the last one was I3. So I do have my first KVL. Let's talk about the second KVL. The second KVL is just about all voltage drops. So I can say 0 equals to what? Equals to all of the voltage drops that are happening over here on the top side, over here. So I can say that 0 equals to what? Equals to 2 times I2 and then plus 3 times I2 subtracted by I3. And then since I'm just trying to look at this from this direction, it is important. At this point, the current that I have that moved through this guy is going to be I2 subtracted I1 by I1. So it's going to be plus 1 I2 subtracted by I1. This is the second KVL. And the third KVL is going to be what? It's going to, again, I'm going to move through this section. Is that so? So if I move through this section, I know that I do have 6 volts as my voltage drop. Is that case? It's like as voltage rise. So if I move through this way, you can see that 6 equals to 3 times I3 subtracted by I2 plus 1 times I3, then plus 2 times, since I'm moving through the I3 direction, times I3 subtracted by I1. So these are the equations that you need to solve. And if you just solve all of them using the 3 unknown 3 equations, you're going to have this answer. By the way, just one mistake happened over here. At this point, I talked about the 6 as voltage rise, but since 7 volts and 6 volts are fighting against each other, at this condition, we have to consider 7 subtracted by 6. So let's test this if these answers are going to be right or not. At this point, for the first one, the answer sheets found out that I1 is 3, so I would put 3 amp and I2 would be 2 amp. Then I do have as I1 as going to be 3 and I3 is 3. So if you do that, your final answer is going to be what? Is going to be 1, which equals to 1 itself. For the second one, I do have 2I2, which means that I do have it as what? I do have it as 2 times 2 amps. And I2 subtracted by I3 is going to be 2 subtracted by 3 is going to be -1. And I2 subtracted by I1 is going to be just 1 itself. I'm sorry, I2 subtracted by I1 is going to be -1 itself. So -1 plus -1 is going to be -2 plus 2 is going to be 0. If you test it for the third one, you're also going to have the same value. So as simple as that. The very important thing that you need to know was about 2 conditions. The very first condition was that when you consider the first KVL, you have to consider these 2 guys are going to fight against each other. It means that those guys are going to subtract with them. Then we do have the second loop. The second loop is over here. At this point, you don't have any voltage source, so you consider all of them as voltage drop. And for the third one, you just do a normal thing. But since we are dealing with some kind of three kind of currents, it is very important while you're looking at this while you're looking at this from this direction, you're looking at I1 subtracted by I2. But when you're looking at this through this direction, it would be I2 subtracted by I1. And the same thing would happen for all of them. So it needs practice. Try to pause the video, think about all of the equation, do it by yourself again, try to solve this one to see that if you get this answer, which we found out is right, and then try to some kind of redo everything. So what would happen if we do have this condition? As you can see over here, for this guy, the situation is a little bit different. Why? Because I do have a current source. And whenever you do have the current source, it would be better to somehow avoid any KVL that would pass through this guy. Because this guy is not, by finding the voltage of this guy, you're not going to find anything. And also, you don't have any clue that what is happening inside the voltage. So imagine that I would write down all of the equations and everything is fine, but I'm going to have another problem because I don't know anything about the voltage of this guy. You don't have any resistance, you don't have anything related to that. So it would be 3 equations, 4 unknowns. At this point, it would be better to somehow using another way. And while I'm using a mesh analysis, at this point, I have to use a loop analysis. So it means that I can consider one of these loops or one of these, I cannot say it as a mesh because it's going to be divided into 2. I consider one of them as one loop and consider another one as mesh. Then try to solve that. Let's imagine something like this. Let me use another color, like this one. So I'm going to consider the fact that I'm going to use this red one, this blue one, and I'm going to use this blue one. So I'm still going to have my I1, and then for I3, I'm going to find the relationship between I1 and I3 because I know the 7 amp. I will talk about it right now. So let's write down the first KVL, which is going to be for the blue one, or the, let me just use that specific color, the KVL 1, which says that 7 equals 1 times, obviously we are talking about this point, I1 subtracted by I2. And what is going to be another voltage drop because of this, another voltage drop because of this, is going to be plus 3 times what? I3 subtracted by I2, and it's going to be plus 1 times I3. So another KVL number 2 is going to be related to red one. Let's use that specific color. The KVL number 2 is going to say that because everything is about the voltage drop, so 0 what equals to 2I2 plus 3 times I2 subtracted by I3 plus 1 times I2 subtracted by I1. Another equation that I can say at this point is the relationship between the I2 and I3, because at the end of the day I only need to have I1 and I2, or maybe I1 and I3, doesn't matter because I do have only the main 2 equations. But as you can see over here, I do have 3 unknowns and only 2 equations. I have to find one of them based on another one to only have 2 equations, 2 unknown. So for the third one, I'm going to say that based on the case I1 equals to what? I'm going to say that I1, if I consider this part, this is I1, right? And I know for a fact this is I3. And I know for a fact this is going to be 7 amp. So we'll say that I1 equals to 7 plus I3. If I rearrange that, I don't have to rearrange that. Only thing I have to do is that move this 7 to another side. It is barely considered as a rearrange. I1 subtracted by 7. So I do have any information about I3 that I need. So I have to only put I3 over here inside one of these equations, and based on that I do have I3 as I1 subtracted by 7. Solve these 2 KVLs and bam, I do have everything that I need. And obviously you can check your final answers with this one, and that would be it. Right now these 2 questions are a little bit complicated, but I thought it would be better you guys to have it in order to use them in your equations, and obviously try for you guys to expand your knowledge related to the KVL and mesh analysis. So what would happen if I do have independent source? If I do have the independent source, everything is fine. But the question is that what would happen if I do have dependent source? So when you have a condition like this, that there is a dependent source, you don't have to worry about it, because this guy is going to say that this specific, let me just use another color. This specific section is going to be what? 4 times IO, which is 4 times the current that goes this way. And we know a fact about the IO. Actually, IO is going to be I1 subtracted by I2. So it's not that some kind of hard thing. The only thing that we have to know is that we can consider this one so in our equations, but instead of just writing it out as 4IO, we would write it as 4 times I1 subtracted by I2. So let's do it. Again, let's do the normal thing. We do have 3 meshes, one this one and another this one. Let's write it down and try to solve them based on that. So for the first KVL, we do have it through the I1. I'm going to use this. So the KVL number 1 says that 24 equals 10 times, as you can see over here, moved to 10 ohms, I1 subtracted by I2, then plus 12 times I1 subtracted by I3, right? Then for the KVL number 2, we do have it as there is no source, so there's some kind of no voltage source. I'm going to say that 0 equals to 24 times I2 plus 4 times I2 subtracted by I3 plus 10 times I2 subtracted by I1. So maybe one of you would ask how you can simply just write it down, because we do have 3 currents and it would be a little bit confusing. So let's look at the whole mesh. For example, mesh number 2. Which way you're moving? You're moving through this way, right? At this point, what currents do you have? On the left side, you only have I1. On the right side, you have I2. At this condition, we say that I2 is probably going to be bigger than I1. So it would be I2 subtracted by I1. If I move through I3, what would happen? If I'm going to move through this point, what do I have? On the right side, I do have I3. On the left side, I do have I2. 4 times I3 subtracted by I2. If I move through that guy, what do I have? From the perspective of I do have I3. I do have I1, 12 times I3 subtracted by I1, and it's simple as that. That's way you can some kind of make sure you're not getting any confusion. So for the KVL number 3, just like that. For the KVL number 3, what I got, I do have, again, all of them it would be considered as a consumer. All of them we're going to consider as voltage drop. We don't care that we do have a dependent source. We're still going to consider it as a voltage drop. So it means that 4 times. As I just told you, on the right side, we do have I3. On the left side, we do have the I2. Then we are going to move through the next one, which is going to be just a normal 4 IO, which is going to be what? Is going to be my, as I know, IO is going to be I1 subtracted by I2. Then I do have another voltage drop, plus 12 times I3 subtracted by I1. So at this point, I do have 3 equations, 3 unknowns. And you can obviously solve this one, and in order to find all of the things that we need, it's about some kind of mathematics. It's all about mathematics, so obviously you know better than me how to solve this one, but finally you can check your answers, that your IO should be 1.15 amp. So at this point, 1.5 amp. So consider that and just put it, use all of those equations, and you can find I1 through I3 itself. So that's the ones we were talking about. So this is the kind of the super mesh we were mentioning, that at what point we are going to use that. So what is the super mesh, or specific kind of mesh, or we can kind of consider as a loop, at a point that when an ideal current source is on a branch shared by 2 meshes. If you guys remember, we talked about it in the previous question over here, that I told you instead of just using the normal mesh that was like this from this point, it would be better to use a super mesh is going to move through here. It means that this guy is going to be considered based on 2 mesh, and we can use it in order to solve that equation. So at this point, we are going to use a super mesh. And why we need that? Because you cannot write KVL through an ideal current source, because its voltage is completely unknown. For the voltage, we need the resistance and we need the current. Yes, we do have the current that will move through that, but what about the resistance? We don't know anything about it. So this is going to do 2-part solution. The super mesh KVL, we are going to write one KVL equation around a new larger perimeter loop, as you can see over here. If I consider that, I'm going to write down one equation through that point, and then you have the concerned equation. Write a simple algebraic equation relating to the mesh currents, and it's going to be directed by the current source. It means that I'm going to consider the currents that move through here, or I2, as I1 plus this guy, or based on the direction, could be subtracted. By using that, I do have a very simpler condition and situation. I can use it for solving anything that I would like. So imagine that we do have a question like this, and at the very first glance, we say that there are 2 meshes. It should be 2 equation, 2 unknowns. But the good thing at this point, we do have the super mesh. It means that we do have it only 1 mesh that I have to consider. Why? Because I can write down I1 and I2 using this way, and I can find a relationship between both of them. So let's start it. The super mesh is going to be the big one, right? So at this point, I'm going to write down as 10 volts Let me just write down again, and then we are going to try our answer to the answer sheet itself. So 10 volts, imagine, some kind of, remember, since we are going to talk about the super mesh, as you can see, unlike the previous parts that we have only one source, we have two sources. Since the direction of the sources are opposite, it means that they're going to fight against each other. So at the left side, instead of just saying that 10 volt or 5 volt, I have to write down 10 volts subtracted by 5 volt equals all of the voltage drops. All of the voltage drop, the very first one is happening because of 6I1. Another one happens because of the 3I2. Another one is happening because of 7I2. And another one is happening because of the 4I1. Then I know something, I know a relationship between I1 and I2, and it says that I1 equals to what? Because of this one, this is the direction of I1, this is the direction of IS, or some kind of my source, it would be 1.5, and this is going to be I2. So at this point, I can say that I1 plus 1.5 is going to be I2. Or I can simply say that I2 subtracted by I1 is going to be 1.5. So at this point, instead of just writing down as I1 or I2, I can just keep the I1, and instead of I2, I would write it down as what? As 3 times I1 plus 1.5. I can write it as 7 times I1 plus 1.5, and I can just keep the 4I1. So if I rearrange all of those equations and everything together, we can find I1 and I2. So let's do it. So on the left side, I do have 10 volts subtracted by 5 volt. I can get rid of that, and I can say simply this guy is going to be what? Simply this guy is going to be 5 volt itself. On the right side, I do have all of the numbers that I need. I do have the 3 times I1 plus 1.5. So I can simply get rid of that and say that 3I1 plus 4.5, right? So it would be 3I1 plus 4.5. Then I can do the same thing over here. I can just multiply the 7 by I1 and 7 by 1.5. If I do that, I do have the 7I1 plus 10.5. So just write it down. This would be 7 times I1 plus 10.5. And I'm going to some kind of rearrange all of them, since right now I don't need this guy because I already have it. And I don't need this guy, I already have all of them. So it means that my 5 volts equals to what? Equals to 6I1 plus 3I1 plus 7I1. It would be 9 plus 7, 16I1 plus 4.5. And then I do have, oh, sorry, I forgot about the 4I1. So I also consider that. So I do have 6 plus 3, 9 plus 4 is going to be 13 plus 7, 20I1 plus all of the numbers, 10.5 and 4.5 is going to be 15. So it means that if I rearrange this one and move this guy over here, it means that 20I1 equals to negative 10, and I1 is going to be what? Is going to be negative 0.55. So if I consider that, I know that I2 is going to be I1. What? I1 plus 1.5 is going to be 1 amp. So if I consider that, my I2 is going to be my 1 amp subtracted by I1. You see, negative half is going to be 1.5. By the way, what does it mean by negative half? Means that the direction I consider for I1 is not that way. Actually, the direction should be in this way. So that's just the case. But again, doesn't matter. You can just write it down as the way you want. So by this way, we somehow prove that not all of the questions are that some kind of challenging. We can just solve them in a very simple way. So what about the dependent source? As I just told you, the good thing about the dependent sources is that you can consider them as a resistance or as whatever is that, because you can again consider them as just a voltage drop, and then try to find a relationship between them, because obviously these guys are talking about an equation. For example, this guy is VD, and VD talks about part of your circuit itself. You can just write it down. Instead of this guy, you can write that equation related to that, and you can simply solve anything you need. So at this point, let's see. So define the controller. We are going to write an expression for the controlling the variable of Vx in terms of the mesh currents, right? Imagine that I do have it as Vx. So my Vx is going to be Rx times I1. For example, is 2 ohms times I1. Then we have to substitute into the KVL. Imagine that we had the KVL, that we had some kind of dependent source. Replace the dependent source in its KVL equation with the expression that you found from the step. For instance, there was a relationship between VD and other part of the equation, and you found something like this. For instance, this is all an example. Finally, you have to solve as normal. The system of equations is now entirely in terms of the unknown mesh currents. Here, you don't have any problem with that, but caution. The most common error is about the sign mistake during substitution. It is very important for you guys to make sure that you consider the signs. Double check the polarity of the controlling variable and dependent sources all the time. Whenever you're trying to use your dependent variable or any other kind of variable, it doesn't matter. It's just a normal one or a dependent one or independent one. Try to consider the fact that you have the positive and negative. While try to use that, consider that as a sign. So here's the final inspection before the sign off. First of all, we were talking about the KVL residual. You have to plug your solved currents back into each KVL equation. As I just told you, this is a very important step, because if you don't do that, you're not sure that your answer is right or not. Maybe you did something wrong. Maybe you used some kind of misspelled sign, or anything could happen. Does the sum of all of the voltages is going to be equal 0, or does the sum of the voltages on the left side, which is going to be your source side, is going to be as the same as your some kind of resistor side? If not, it most likely causes the shared resistance sign error or the source polarity error. So these two are so common mistake. What does it mean by the shared resistor sign error? If you guys remember, whenever we had a resistor and on the right side it was, and on the left side it was another current, sometimes you're going to miss the match. Or maybe if we do have 3 currents, you are going to miss that, or you're going to be a little bit confused, or you're going to have a problem with the source polarity. So you guys, I know in some kind of the questions that when we do have the 2 sources and both of them, but in the first is in one direction and both of them were inside the one mesh, you have to subtract them. If one of them was in, for example, from negative to positive, another one from positive to negative, you have to consider that it would be better to consider one of them as your reference as a positive and make another one as negative. So another thing that you can use, which we didn't talk about it, but still is going to good usage, is about the power balance. It means that you have to calculate the power for every element. Total power absorbed, that does the power that is consumed by your resistors, is going to be the total power delivered, all of the power that your sources are going to produce. If not, you have to change the signs conversion for source. And voltage consistency. Pick one component, calculate some kind of the voltage across it using Ohm's law, V is equals to R times I. Now calculate it using the KVL itself. So it's going to be around the loop, obviously. Do the values are going to match? And this is going to be a great way to catch a sign or path errors in anything you have. So again, be very careful about some of the pitfalls. The pitfall number 1 is about the incorrect shared current. All the time, when we are talking about the resistor and the currents that those guys are going to share, we are talking about the fact that the sign should be negative. We don't have any positive sign. So it's R1 times I1 subtracted by I2, I1 subtracted by I3, I2 subtracted by, it could be anything. Remember that. Then we do have the positive of diagonal term. It means that this is going to do something related when you're trying to use some kind of matrices in order to solve your equations. It's not very important. And finally is would be about the pitfall number 3. It means that the KVL through a current source. As I just told you, whenever you have a current source, it will be better to use the supermesh analysis. It means that on that point, instead of just considering that current source inside your mesh, try to move around it and find the relationship between the currents beside of that. That would be so helpful for you. So at this point, we were talking about a very interesting topic that was related to the mesh analysis. Everything is related to KVL. I was completely talking about how you can use that. The first one, you have to consider the mesh. Then you have to consider the current go through each mesh. And after that, you have to write down the KVLs and everything related to that. We also consider some exceptional moments when we do have a current source and when we do have some kind of source. We found out that how we can use the supermesh analysis and everything related to that. So I tried to solve a couple of equations and questions for you inside this one for you guys in order to completely understand it. For the next chapter, probably we are going to touch another analysis which we call as node analysis. And node analysis would be way simpler than that. I cannot say way simpler. It's going to be better than that because it is very rare that we are going to touch maybe more than 2 equations, 2 unknowns. That's a good of that. But at the KVL, it's very common to reach that fact. But anyways, if you have any question, you can comment me down below. We'd be more than happy to help you. If you like this part, do not forget to like and share it with your other friends. My name is Mahmoud Kiasari. Have a great day, night, whatever. See you around.